Consider the function g of x equals 2 times the absolute value of x minus 1 minus 8, defined over the interval of negative 4 is less than or equal to x is less than or equal to 7. What we want to look at is where is this function increasing and where is it decreasing, first of all. And when we take a look at this graph here, if we were actually drawing it, what I did is I put my points in, and then I took my pencil and I went down along these points, got to the very bottom point, and then I went up with these points. What I sometimes say is we went down, 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 down. Then we got to the very bottom, and then we went up, 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 up. So if you wrote down the notes yesterday, what we said is we were kind of going downward or we're kind of going upward. And that corresponds to increasing or decreasing. So if we want to state where the function is decreasing, what we're looking at is we're looking at where. And those are going to involve the x values. So 1, 2, 3, 4, 5 here. I'm trying to put a mark right there. And we're going to be going downward until we get to the very bottom point. So again, I'm going to put another mark here. In this part, and I'll try one more time with this mark. In this part of the graph, we're going in the decreasing direction. And that is between the value of 1, 2, 3, 4, negative 5. X is between negative 5 and 1. We didn't specify whether we wanted interval notation or not, but if you like the interval notation, that would be negative 5, comma 1 in parentheses. Notice that we picked the x values. That's where we are decreasing. Question?
What greater sign do you have like an equal sign below it?
We don't need the equal sign. It's where. So we're starting here, so we don't need the starting point. Then we went down all the way here, and then where we ended, we don't need an equal sign on that. So we've done the decreasing, and this graph isn't too overly complicated. But remember, we went down, 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 down. Now we're going to go up, 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 up. There's our increasing. And where we're going to increase is from here over to here. And he's right. We don't need to keep in the starting point or the ending point of this. We're starting when x is 1. We're finishing 1, 2, 3, 4, 5, 6, 7 over here when x is 7. And all of those values in between 1 and 7 are where we are increasing. If you prefer, it's going to be 1 to 7. When we look at the domain in part B, again, domain and range even might be helpful if you draw the rectangle. I consider it a good technique. It's just that I don't draw my rectangles very well. But close enough. Because we have a starting point and an ending point on here, we have a specific domain. 1, 2, 3, 4, negative 5. And then over to the right part of the rectangle is 1, 2, 3, 4, 5, 6, 7. So it's going to be 5 is less than or equal to x is less than or equal to 7. those are points on the graph, so we do want to include them. We don't have any open circles on this particular graph. The range is dealing with the bottom of the rectangle to the top of the rectangle. Well, 1, 2, 3, 4, 5, 6, 7, -8. Remember that range is a y. And then 1, 2, 3, 4. And again, we do want to include those values in our domain. They are specific points on our graph. We make our squiggly bracket there in y bar for our set builder notation. Am I going too fast? So next, state the zeros of the function. Remember that zeros are the x-intercepts. I also like to call them roots. What's one of the x-intercepts on here?
Zero. -5, 0.
1, 2, 3, 4, 5, +5, 0. And the other one, Tiffany?
-3, 0.
Is -3, 0. 1, 2, 3. There's the -3, 0. Here's the +5, 0. Where the graph crosses the x-axis. Letter E. State the interval over which g of x is less than or equal to 0. So we're going to visually draw something in like we did yesterday. G is less than or equal to 0 is here. It happens to represent a horizontal line. And today we're going to look at less than or equal to, whereas yesterday we looked at greater than or equal to. So we want to look at the interval where the graph is below that light purple line. So where it's below that light purple line is actually corresponding in this particular picture to our roots. Everything from the left root to the right root has our graph underneath that. So it says state the interval, so we're going to go from -3 to +5. We have less than or equal to 0. So we're looking at all these y values that are less than or equal to 0. Because there's an equals in this problem, we want to have the brackets. So from everything from here to there. Letter F. It says evaluate the function. Evaluate g of o by using the algebraic definition of the function. So if you look back at the top of your page, what you see is you see g of x equals 2 times the absolute value of x minus 1 minus 8. So what we're going to do here is we're going to figure out, well, what does g of 0 equal? Well, g of 0 means that we're going to take this value of 0 and we're going to put it back into our function wherever we see x. So when we come over here, we've got 2 times the absolute value of 0 minus 1 minus 8. Again, we took our value, we're putting it into the function. It's an input. And now we're going to solve this equation to figure out what we're going to get out of it. So we're going to simplify. Inside our absolute value bars first, it's going to be 2. 0 minus 1 is negative 1 minus 8. So what is the absolute value of negative 1? Matthew?
1.
It is. So when we fix that, here it's 2 times 1 minus 8. 2 times 1 is 2 minus 8, which gives us negative 6. Now we follow the directions here, but if we were really thinking, we could have gone back at the picture and looked at it on a graph. This is g of x, so that means when x is 0, what is our corresponding y value? Well, it's 1, 2, 3, 4, 5, negative 6. Hopefully we ended up with negative 6, and we did. What do we call this point right there? 10. And it is. This is the y-intercept. So when we look at letter G now, it says, are there any relative maximum or minimum values on the graph? If so, state the coordinates. So when we go back and look at the picture, a minimum is a low point. We happen to have this low point right here. Now, that ordered pair is positive 1, and then 1, 2, 3, 4, 5, 6, 7, 8. It is 1, negative 8, which is a relative min. We don't have a high point on the graph, a relative max. But over here, it says, state any absolute maximum or minimum values. The thing is, when we find the relative min of 1, negative 8, if we go back and look at the picture, it also turns out that 1, negative 8 is the very lowest point on the graph, which also makes it an absolute minimum. But we have absolute maxes on this graph also. We have 2 of them. And the first one is what I call the starting point of the graph. It's a high point in the graph. It happens to be the starting point in this particular picture. 1, 2, 3, 4, negative 5, 1, 2, 3, 4. Negative 5, 4. And then there's also an absolute max, another order pair, over here at what I, in this particular graph, call the ending point, the very last point that we look at if we're reading the graph from left to right. And it is at 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. you need to be able to think about functions in all their forms. So we've talked about functions when they're written as ordered pairs. Yesterday and today we've looked at graphs, pictures, graphs of functions. And we haven't talked about tables much. So we're going to finish with looking at the tables. And first of all, this says it's a continuous function. Has a domain of x's between -6 and 13. So this means that there's more values than just those. It's just those are the ones that we can see. With selected values shown below. The function has exactly 2 zeros and 2 turning points. And I want to look at the zeros here for a second. This is a 0, which I'm going to put a root there. And this is a 0 or a root of the function. And when we look down here, it says state the interval over which f of x is less than 0. So by the way, if we graphed f of x equals 0, what does that look like? Horizontal line. But on this one, we're not looking at it. That's what makes it tougher. But what we're asking ourselves is, where are the y values less than 0? That's what this question is asking. And where are the y values less than 0? They're here. In other words, it's in between. We're in between -1 to 8. No equals, so we're going to have parentheses. So there's the interval. If you prefer, -1 less than x less than 8. And I am going to look at it graphically in just a minute. So if that doesn't make sense to you, I will put it in terms of the graph.
How did you know that? -1 here.
So when we come over here, it says state the interval over which f of x is increasing. So we're still looking at y values, but when we answer the question, we're going to answer in terms of x. And if we look at the y values here, 5 to 0, does that mean we're increasing? 0 to -2, are we increasing? Nope. -2 to -4, are we increasing? Nope. But when we get over here, -4 to -1 is increasing. -1 to 0, we're getting bigger. 0 to 3, we're increasing again. So where we can say we're increasing is in between here. And again, if you don't see that on the table, then let's look at the picture just to make sure that we didn't do something wrong here. But we answer in terms of the x's. From 3 to 9 is where we're increasing. So I know you don't have a graph on your paper, but let's look at the picture anyway. I'll draw the graph up here, maybe. So if we look at these points on here, -6, 5. Here's a point. And -1, 0. 0, -2. 3, -4. 5, -1. 1, 2, 3, 4, 5, -1. 8, 0. 9, 3. And then 13, 1 is roughly here. And the thing is, continuous means that we're not just looking at a bunch of ordered pairs. We're looking at this all together. So it goes something like this. I'll do the best I can. So there's roughly the picture. And then, if we go back and look at the questions again. State the interval over which f of x is less than 0. We just talked about how we're looking at where it's less than 0. From here, -1, to here, 8. Our graph is underneath there. On the other part here, state the interval over which f of x is increasing. We went down, 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 down. We got here to a low point. Then we went up, 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 up. And then we went down, 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 down. So we're increasing from here to here, which is 1, 2, 3, over here to 9.